Okay, now the second example for you. So an object 2.5 centimeters tall, so that's HO, 2.5 centimeters, is placed 9 centimeters, so DO, in front of a convex mirror. Okay, so when you think convex, you should think you need to make your F should be a negative, okay? You need to manually put that in. That has a center of curvature, so that's big C, of 8.0 centimeters. Now, this needs to be negative, okay? Negative. So, now remember, if we had a sphere, so if we had a sphere, okay, this would be the center for a convex mirror. So it would be like the slice of a sphere on this side, okay, and here's our center. Now remember that this needs to be negative because it's going to be on the opposite side of where the object is. So here's your object. Here's your center. So since your center is behind where your object is, that's why it's negative, okay? And remember we said that the focal length is half of the center of curvature. So our focal length would be somewhere, or focal point, sorry, would be right there. And so then to find focal length, it's -8 centimeters divided by 2, which you could probably do in your head, I hope, is 4 centimeters. Okay? So this is what we know about our object, about our object, and we're asked to find the magnification. So we're looking for M. Okay, so alright, so the formula that we'll end up needing is our M is equal to negative DI over DO. You could, and the reason I have to use that one is because you might wonder, well, why can't I use big M is equal to your HO and your HI? Well, we're not given anything about our image, and I can find DI using information about my F. So this is the formula that I'm going to have to use as to get my end answer. So I'm given DO, but I don't have DI. So I'm going to find DI using 1 over F is equal to 1 over DI plus 1 over DO. Okay? So again, this will be my first step, and then this will be my second step. So we don't actually use the height at all in this question. So you just have to kind of discern which values that you can use. All right, so our first step, 1 over DI is equal, well, do you want me to show you? I'll just explain. So to solve for this, right now it's added to 1 over DO, so I'm going to bring this to the other side, which means I'll be minus E. So I have 1 over DI is equal to 1 over F minus 1 over DO. Okay. So 1 over DI is equal to 1 over negative 4 centimeters minus 1 over 9. Okay. This gives us an answer of negative 0.361 centimeter inverse. So to solve for DI, I need to go 1 divided by negative 0.361 centimeter inverse, and that is equal to negative 2.796, etc. centimeters. So this negative indicates indicates to us that it is virtual. Okay? And I'm kind of running out of space here, so I'm just gonna move down. So now I can do step 2. So step 2 is big M is equal to negative DI over DO. So that's equal to a negative times by a negative, which is 2.769, etc. centimeters, all divided by 9.0 centimeters. So my magnification then is positive 0.30769. No units, right, on magnification. And so I can set it to my signes is positive 0.31. And I'm just emphasizing the positive to show here this means it's upright. And since this is less than 1, obviously then it means that my magnification, it means that the image has gotten smaller. Alright, so that's your examples. So now I'd like you to do the practice problem on the back. And you can do all of your questions in your workbook. Now, I didn't circle the questions in your thing, but you have to do most of them. The only one you don't have to do, I think, is number 35. Like number 9, number 10, you don't have to do, but all the rest you have to do. So I'll leave the key for you, be up here on the lab bench. So please take a look at it if you need some help. And then you'll have a quiz tomorrow on lenses and mirrors. 2 questions on lenses, 2 questions on mirrors, and there will be a question where you have to draw a ray diagram for it as well. So practice your ray diagrams, review your notes, watch some YouTubes online. That Doc Physics is really good. Your textbook has a lot of really good explanations. So just seek out those resources if you need some more help to review. This is, lenses and mirrors is a big, kind of topic. It was a lot of work in a short amount of time. So good for you, and just keep up the work, and then, hopefully you'll do well on your quiz.